Okay, so now we actually get down to a complex number, like what is a complex number? So if we look at something, so this here is what's called a complex number. So if we take 3 plus 4i. So this here is an example of a complex number, and you'll notice that there are two parts. There's this part over here, okay, and then there's this part here that has the I attached onto it. So what we can say is that, so the 3 here, or this part here, so this is what's known as the real part. Real part. And then this part here, this is what's known as the imaginary part. So they're imaginary numbers because it has this imaginary part. So this is the real part, and then this is the imaginary part. So you can take like a general rule for complex numbers, or like a general kind of formula. So the general formula, or the form, so the form of a complex number it's generally in this form. So A plus B I. Okay, so this is generally the form of it. Where, and we looked at this in the last part, where I, for this imaginary part, is equal to the square root of -1. So it looks something like that. So this A, so if we take this example here, so this A, this 3 is represented by the A, and then this 4 is represented by the B. So notice that that 4 is the coefficient, or it's a number that's in front of I. So in the general form, or the mathematical form, so it's, this part is the real part, so A plus B is the coefficient, which in this complex number is 4, and then I. And remember, I is just equal to the square root of -1, and we looked at that in the last lesson. And in maths, they like to use like letters to represent complex numbers. So if we take complex numbers, they're represented by a capital C. So this is the letter that they use to represent complex numbers. So just some other examples of complex numbers. So you could have 5 plus 2i. Okay, so again, this is the real part, this is the imaginary part. You could have something like this. So 4 plus 3i. Okay, so again, this is the real part and this is the imaginary part, and together this real part and imaginary part, together they make up a complex number. And again, it's just in this general form. So in this case, this is representative of A, and this 3 is representative of B, and then the I is representative of I as well. So this is the general form, and remember, I means in relation to imaginary numbers, I is equal to the square root of -1. Now you can take any real number. So let's say if we take the real number 5, for example. So that's just a real number. Now what we can do is we can actually turn this into a complex number by, all we do is we just add 0i to it. Okay, so remember, any real number that you have, you can turn it into a complex number by just adding 0i. Okay, so again, we've taken just 5 on its own as a real number, and we've turned it into an imaginary number by adding this bi bit, okay, which in this case is plus 0i. So we can turn it into an imaginary number. So again, the imaginary part, or the real part, is 5, and the imaginary part is 0. So, and the same thing happens as well if you were to take an imaginary number like this, so 6, so -6i, so this -6 is an imaginary, this -6i is an imaginary number. And what we can do is we can turn it into a complex number by just putting 0 here in front of it. So this 0 represents the real part, and this -6 represents the imaginary part. So that's just a way that like any number. So if I take 6, for example, I can easily turn it into a complex number by just adding 0i to it, and now it's in this form here. So we have the real part, which is 6, and the imaginary part, which is 0i. And then likewise, if I have, so again, just like looking at this similar kind of example, if I have the imaginary number, let's say minus 3i, so that's just an imaginary number. If I want to take it in, turn it into a complex number, it has to have the real part and the imaginary part. So just like this, there's just the imaginary part. If I put a 0 in front of it, like so, that's the real part. So now it's a complex number. It has the real part, which is 0, and the imaginary part, which is minus 3. Sometimes what you'll see then as well, so again they use this letter C to represent the set of complex numbers. And sometimes as well they'll write, let's say if I want to like talk about an individual complex number. So we use, like, for example, a small z and a 1, and then we can make that equal to a particular complex number, like 2 plus 3i. Okay, so this z1 just represents, it's like a placeholder for this complex number, which has so remember, this is the real part, and then the 3 is the imaginary part. So you could have something like this as well. So z2, so that's just a representation for a complex number. So z2 is equal to minus 2 plus 5i. So again, this is the real part, and this is the imaginary part here. And then this lowercase z, for example, this is just used to represent a complex number. So this is just complex number 1, complex number 2. And it's generally represented by a lowercase z, and then, for example, a number after it to indicate. So this is the first placeholder for this complex number, and then this is another placeholder for this complex number here. So if we just have a look at these numbers here. Okay, so 1, 2, 3, and 4. And what we want to be able to do is, when we look at this, we want to be able to identify the real part and the imaginary part of each of these numbers. So if we start with this very first one here, so what's the real part? So what I would ask you to do is just pause the video, look at each of these, and then indicate for each of them what's the real part and what's the imaginary part. Okay, so if you've given them a go, so we go through the answers now. So if we take this first one here, so what's the real part of this? So this 2 here is the real part, and then this minus 5i is the imaginary part. Okay, so that's question 1. So question part 2. So if we look at this one, so what's the real part and what's the imaginary part? So this here is the real part, so this is a real number, minus 1. Okay, it's a negative integer. And the imaginary part then is this plus I'm sorry, we shouldn't say 2, it's just going to be minus 5. So in this case then the imaginary part is just 2. So you don't need to put in the I, you're just representing the number that represents the imaginary part. If we have a look at this one then, so 6, so remember, I can make this an imaginary number by just adding 0i, okay, like so. And what we want to do is, so this 6 is the real part. Okay, so this is question 3. And then this 0 is the imaginary part. So 0 is the imaginary part, like so. And then again, if we take this number here, so this is an imaginary number, so we can make it into a complex number by just adding 0 at the start. So again, then if we want to identify what's the real part, it's this 0 here. And then the imaginary part is going to be this minus 2. Minus 2. Okay, so hopefully that makes sense. So this is basically what we've looked at, is just the form of a complex number. So this is an example of a complex number. It has the real part, which is 3 in this case, and then it has the imaginary part, which in this case is 4, and it's just in this form. And this is the general form, a plus bi, where a is the real part and b is the imaginary number, the imaginary part, and then I is equal to the square root of minus 1. So this real part and imaginary part together is what's called a complex number. And we've looked at some examples. So some of these examples here. So we can take any real number and turn it into a complex number by just adding 0i. And similarly, we can take we can turn it into a complex number, and similarly we can take an imaginary number and turn it into a complex number by just putting 0 in front, so 0 minus 6i. So this now is a complex number. Sometimes individual complex numbers are represented by a lowercase z, so this is lowercase z1, so this is like just a placeholder for this complex number. And then this is a placeholder for this second complex number here as well. So sometimes you'll see that, and we'll look at examples of that as we move on. So what we need to be able to do then is we just need to be able to identify a complex number and then identify the real part and the imaginary part of a complex number. So hopefully that makes sense, and thank you for listening.